an entire galaxy. We'll get into more details of like there's actually an afterglow and all that stuff, but basically they're transient events. So it's not like once this gamma ray burst happens, you can observe it at that same intensity for many, many minutes or days or whatever, although there is a part that we can observe later on at a different wavelength. But for those short, very short periods of time, depending on the length, if it's greater than 2 seconds, it's called a long gamma ray burst or a long GRB. If it's less than 2 seconds, it's called a short GRB. Long bursts are associated with the collapse of massive stars or hypernovae. So these are just supernovae that are really, really big. So like massive stars collapsing, probably when these massive stars collapse. So you were right. Someone said, I think it was Stephen, who said that they might become black holes. So basically, gamma ray bursts are not a black hole yet. Basically, massive stars collapsing, producing a supernova, hypernova type of situation, ultimately might collapse to a black hole. But before that point, this gamma ray burst phenomenon is happening. This transient event is happening. So the long GRBs are associated with the collapse of massive stars or hypernovae. And short bursts are associated with mergers of binaries composed of neutron star, or neutron star black hole. So depending on which gamma ray burst, sometimes you could also have the merger of neutron stars, as well as a neutron star and a black hole, or a black hole and a black hole, and that is going to be associated with a short gamma ray burst. In fact, we have evidence of this because we picked up on gravitational waves from a short GRB, and that actually gave us evidence of the fact that short gamma ray bursts are in fact associated with neutron star, which is very I think gamma ray bursts happen when a black hole swallows a star. No, so we just spoke about the association. So long gamma ray bursts happen when a massive star collapses. So it's a part of its death. So when a star collapses on itself because it has run out of nuclear power and it's collapsing on its own gravity, we get something called a supernova. If it's a huge event, we might even call it a hypernova. So that's just a supernova, but bigger. And during such a supernova, we can have something like basically a long gamma ray burst. Short gamma ray bursts are associated with something like a neutron star merger. So this would be a binary of neutron stars finally collapsing onto each other and producing a short gamma ray burst, as well as it could be a neutron star black hole combination or a black hole combination that's merging. So so I think sort of yeah. If you meant a neutron star, then yeah, sort of something like that would be a short. So there's different categories: long gamma ray bursts versus short gamma ray bursts. If it was the end of the world, what? In August of 2017, for the first time in history, multi-messenger observation. Oh! Listen to this. This is just what we talked about. In August of 2017, for the first time in history, multi-messenger observation of a short gamma ray burst was performed by the LIGO, Virgo, and Fermi collaborations, confirming the association of short gamma ray bursts with a binary neutron star merger. So, by the way, I was in grad school at this time. And when this result came out, that was the first confirmation of the association of neutron star merger with a short gamma ray burst. Before that, it was simply theorized that short gamma ray bursts are associated with neutron star, or neutron star black hole mergers. But now we actually had confirmation. So we call this multi-messenger. Hi, Ben. Happy 2025 to you and your simply adorable cat. Thank you. Thank you so much. Happy New Year. Happy New Year to Ben. Hello. So multi-messenger, as in we get the light in terms of gamma rays. We got the gravitational waves in terms of in this case we picked it up with LIGO, Virgo, and all that. And we might even see, actually we'll talk about it later, we might even potentially see neutrinos. Fuji. No. How about no?